Hi, Assalamualaikum and good morning, everyone. Those online can say hi. Hi, Fadli. All right, today we continue our online class series, part 5. Today I will discuss chapter 6, light and optics. Okay, before that, let's refresh some important points in this topic. Okay, for this topic, chapter 6, the first part we discuss about okay, refraction. Okay, so in this part, we discuss about what happens to light when travel from denser to less dense to denser. Okay, refraction definition: the change in the direction of wave due to change in speed of wave as the I will use the word light now. Okay, the change in the direction of light or the bending of light due to the change in speed of light as the light travel or passes through different density of medium. Okay, so in this case the medium refers to transparent medium, something like water, perspex, glass. Okay, so I hope you remember definition for refraction of light. And then we discuss what happens when light travel from denser to less dense. I use the medium easier. Use the medium. Okay. For example, air to glass. Okay. Incident ray. This is the boundary that separates air and glass. At this point of incident, draw normal line. Okay, normal line is 90 degrees to boundary. Angle between incident ray and normal, we call it angle of incidence. Okay, what happens when travel from air to glass? Less dense to denser, speed decrease. Okay, if no refraction, it should travel in a straight line macam ni. So refract towards normal, draw in this area at any places in this area. So you can see angle R here. Okay, so for this one, less dense to denser, dense towards normal because the speed decrease, speed of light decrease in glass. Okay, so bends towards normal or refract towards normal. Okay, let's say from glass to air. Okay, this is the incident ray, normal line, angle I. Okay, if no refraction, it should travel in a straight line. Okay, now speed increase causes it to refract away from normal. So you draw above this line. Mana-mana tempat kat atas ni. Okay, so angle R, this one. Okay, so from denser to less dense, bends away from normal. You can see the angle R is bigger than I. Okay, because speed increase. Okay, when travel from glass to air. So ini konsep refraction you kena faham lah. Okay, and then we discuss the concept of refractive index. Okay, refractive index depends on the medium. Actually represent the density of medium actually. Ability to bend light. Kebolehan untuk membengkokkan cahaya. Ability to bend light. The denser the medium, the higher the density. Sorry, yes, of course. The denser the medium, the higher the refractive index. Okay, refractive index we use symbol small n. Okay, means n is directly proportional to density. Okay, uh, so density for air is we can say lower than glass, means refractive index of air is smaller than glass, but value of n is always equals to 1 or greater than 1. Okay, value n air, okay, ialah 1, sama macam vacuum 1. Okay, the rest all more than 1. Itu refractive index. And then you are introduced to 5 formula for refractive index. First, Snell's law, sin I equals sin R. Second, n equals to speed of light in vacuum of air divided by speed of light in medium. This is speed of light in medium. If you want to determine refractive index of glass, V is speed of light in glass. Something like that. Okay, number 3, you are introduced to this formula. Real depth divided by area. Okay, we have one more for Snell's law. N1 sine theta 1 equals to N2 sine theta 2. And then the last one is N equals 1 over sine critical angle. Okay, so ini formula yang you all boleh guna untuk calculate refractive index or find the value. For example, the value, sorry, this one is not H as it should be. Okay, some book they use a capital H and divide by small h. Okay, some use D as a can. Depends what. It depends on what defined by the book. Okay, so kita ada 5 formula sini, so I hope you know how to use. And then the second one, we discuss about concept of total internal reflection. Okay, what is total internal reflection? It must obey 2 condition, 2 syarat. Light mesti travel from denser to less dense. Sorry, wait terbalik. From less dense to denser. Okay, less dense to denser. Contohnya daripada terbalik juga ni. Less dense to denser. Okay, pagi-pagi ni lupa pula. Okay, contohnya betul dah tadi tu. Nanti saya tunjuk diagram dia ya. Light glass to air, water to air. Okay. And then angle I must be greater than critical angle. Value of critical angle depends on the refractive index, meaning C also depends on the medium. different medium, different C. Okay, or we can say different refractive index, different critical angle. Okay, example kita ada macam ni, semicircular glass block, light ray incident along distance through the center of the semicircular glass block. Draw normal line. This is angle I. Okay. If light suddenly travel at the boundary like this, means angle R equals to 90. So when R equals to 90, that angle I is known as critical angle. Okay, so ini ialah critical angle. So when suddenly the angle I is greater than C, increase I, angle I more than C, of course the angle of refraction will be greater than 90. When greater than 90, it will go down here. When go down here, we don't call it refraction anymore, we call it reflection, because go back to the same medium. Okay, so actually if you look at the angle R, this is angle R, okay, for refraction, but we cannot label this as angle of refraction, because this is no longer refraction, it becomes reflection. So when reflection, angle R will be here, means obey law of refraction, that is I equals to angle. So this is total internal reflection. Saya guna simbol saja, senang. Total internal reflection, but in your answer don't write this ringkasan ni, tak boleh, kena tulis penuh. Okay. So total internal reflection, light travel from denser to less dense, and then angle I more than C. Mesti penuhi dua syarat ini. Kalau hanya satu saja, tak ada. Mesti dua-dua. Okay. Compulsory to follow these two conditions. Okay. Ingat dia mesti denser to less dense. Saya pun dah silap tu. Maksudnya glass to air lah macam tu, water to air. Okay, baru berlaku total internal reflection. Okay, application kena ingat yang mirage. Okay, kita dah belajar mirage, the formation of rainbow. Okay, ini semua kita kena tahulah. Okay, total internal reflection. Kita ada periscope juga, application. Okay, by ni semua kalau soalan ni keluar dalam essay, dia boleh panggil you all modify soalan section C ataupun soalan section B. Ni boleh dikeluarkan soalan sama ada choose the best one ataupun modification. Okay, teacher can speak louder. Okay, sorry. Sound, maybe sound problem. Sekarang clear tak? Clear tak, Fadlin? Sebab tadi mic saya terletak tepi. Okay. Okay, sorry ya. Okay, boleh ya. Okay, kita balik ke tadi sambungan dia. Okay, total internal reflection must obey these two conditions. Light travel from denser to less dense. Angle I greater than critical angle. Okay, so application like mirage, rainbow. Ini soalan knowledge, knowledge. Yang 4 markah tu dalam essay. Kalau soalan modification, biasanya kalau ada alat, okay, macam periscope, binocular, ini boleh keluar soalan yang 10 markah tu. Okay. Okay, then we discuss about lenses. Okay, convex concave. Jadi untuk convex concave, you must know how to draw ray diagram. Ray diagram. Complete ray diagram. And then kita ada lens equation. Okay. So ray diagram, you must know how to draw the rules for like convex. Okay, semua term-term kena tahu. Principal axis pass through the optical center. Ini panggil optical center. So this is the principal axis. Okay, focal point. Okay, 2 times focal point. 2F maksudnya ialah 2F ini ialah F ni ialah focal length. Okay, focal length. Okay. So let's say I have this object. So actually there are 3 rules to draw the ray diagram. Okay. Normally yang senang ialah parallel to principal axis then pass through F. Itu yang the easiest. And then another one, pass through center straight line. Sambung je straight guna ruler lah. Okay. Mana dia intersect, that one you draw, at that point draw image. Okay. So object from center ini ialah U, image from center ini V. Okay. So kalau you ada length equation 1 over F is 1 over 1V. But remember for convex, F dia positive. Means bila you ganti dalam ni kena letak sign dia ikut type of lenses lah. Concave, F dia mesti letak sign. Okay. Sama juga untuk V sebab V ni represent the image. Image kita ada real and virtual. Okay. Kalau real, V tu dia positif. Kalau virtual, V negatif. Okay. Sama juga ini F tadi saya dah sebut kan. Convex, F positive, concave, F negative. So substitution in this formula must be correct. So this one ada soalan calculation. Okay, that's a calculation problem. Okay, so secara ringkas saja kalau you all nak tengok. Okay, ini adalah convex. Convex converging. Jadi semua light ray akan converge. Ada yang tak converge, you kena extend to the back then converge. Remember the position. U less than F, U equals to F, U between F and 2F, U equals to 2F, U more than 2F, okay? U at infinity means very far from length, okay? Jadi position ini represent object distance, okay? Object distance, mana you letak? Okay, if you put here means U equals to F. If you put here, U less than F. If you put F and 2F, itu maksudnya U. So that different U will give different type of or characteristic of image form. Saya ingat senang saja boom boom. Read. Okay, ingat dia punya position dia. Ini maksudnya virtual upright magnified. Okay, U less than F, virtual upright magnified. Okay, U equals to F, virtual upright magnified also. Okay, ini at infinity. At infinity. Okay, because it produce a parallel line. Okay, U between F and 2F, real inverted magnified. U equals to F, real inverted same size. U more than 2F, real inverted diminish. U at infinity, real inverted diminish at F. So nampak tak yang ni dua ni dia terbalik sebenarnya. Dia adalah kalau you draw the ray diagram, dia hanya reverse direction you akan dapat. Okay, so itu untuk convex. Ini convex. Kalau concave, dia adalah diverging lens. Diverging. Concave dia lebih senang ingat sebenarnya. Parallel to principal axis, let's say here F, diverge from F. Diverge out. Macam tu. pass through center straight line. So the line will never meet here. Mana pun you letak objek, you akan dapat same diagram seperti ni. Very small image, virtual. So dia selalu VUD. If you look at convex, dia tak ada VUD ya, hanya concave saja VUD. Virtual outright diminish. Okay, at any distance, any U. Okay, sama. So any concave. Okay. Application you kena lihatlah convex di mana penggunaan. Just understand that convex dia size of image depends on U. It can be bigger. Okay, it can be smaller. Okay, kalau untuk VUD ni concave, dia adalah okay, tengok balik ya yang application. Okay, then we discuss about lenses and then we discuss about thin lens formula. Okay, sudah yang tadi 1 over f equals 1 over u plus 1 over v. Okay, and then optical instrument tu okay, you belajar tentang magnifying glass, faham? Magnifying glass, okay, f to f. Untuk magnifying glass, u less than f, u less than f, because you must put the lenses close to the object. Okay, so ini parallel to principal axis, pass through f. Okay, pass through center straight line. So you can see dia diverge out, so it will never meet here. You extend to the back. So image form here. So image ialah virtual, upright, magnified. Sama macam yang you belajar dari atas. Nampak sini. Okay, so ini magnifying glass. Okay, and then you discuss about telescope, and then microscope. Bagian C ya, microscope. Okay, telescope U at infinity. Okay, microscope U between F and 2F. Ingat. So itu untuk hasilkan image dia. Telescope, okay, method to memorize the property of focal length. Just tengok bilangan E dengan O saja. Okay, you nampak sini E lebih daripada O. More number of E compared to O. So means power of eyepiece is more than of objective. Okay, power is inversely proportional to focal length. Thus we get focal length of eyepiece is smaller than objective. Ini untuk teleskop. Sama juga mikroskop, you tengok bilangan O dengan E. Okay, O lebih dari E. Maksudnya PO more than PE. Atau saya tulis ikut atas supaya you boleh bezakan. Okay. Okay. PE less than PO. So, focal length of eyepiece is more than objective. Okay. The difference lagi ialah separation distance between lenses. Kalau teleskop, L equals to FO plus FE atau D pun boleh. Untuk microscope, L is more than FO plus FE. Okay. And then magnification for telescope, FO over FE. Untuk microscope, M ialah MO times ME. Means magnification of objective lens multiply magnification of eyepiece. You kena calculate separate. Separate untuk objective lens dengan eyepiece and multiply, you get for the whole microscope. Okay, so ini adalah what you should know for telescope, microscope. Diagram, ray diagram tak perlu hafalkan, tak perlu. Okay, soalan modification dulu pernah keluar ialah modify a telescope to become microscope. Jadi you kena faham dia punya properties. Maksudnya apa yang you perlu modify. The power of eyepiece, power of objective, the separation distance. Okay, itu ialah modification. Okay, let's look at the last part. The last one, last one in this topic ialah about optical curves. Spherical mirror atau curve mirror. Okay, why we call it spherical? Because we can assume it coming from this sphere, center center C. You see lah, senang. Nanti you all boleh nampak. Center C, this is radius of the circle. Okay, let's say we cut out this part and cut out this part. Okay, saya punya circle tak cantik. Okay, cut out this part and cut out this part. Okay, so saya akan dapat yang ni. Okay, I don't have this one. But, okay, so ini ialah is this part will form a convex. Okay. So if you look carefully, this is also radius. So this center, we call it center of curvature. Center of curvature for convex is behind the mirror. For concave, in front of the mirror. Okay, so I hope you understand this one. If behind the mirror, it becomes virtual. Okay, if in front of the mirror, it is real. Okay, and then the focal length is the midpoint of radius. Midpoint. Okay, so convex, ini convex mirror. This one is concave mirror. Okay, that's why for convex mirror, F and C virtual. Okay, kenapa? Sebab mirror apply concept of reflection. Okay, if you put a screen for mirror, you put in front of the mirror, not behind. Sama juga macam you must stand in front of the mirror, then only you can see your image. You cannot stand behind the mirror. Okay, itu maksud di sini ya. So convex dengan concave mirror. Okay, if you want to draw the ray diagram, you must apply concept of reflection. Kalau lenses, refraction. Okay, so for convex mirror, we call it diverging mirror. Diverging mirror. Ini ialah. So the properties of image form for concave mirror same as convex lens. Analog dia image form. Image characteristic. Characteristics. Kalau you compare mirror, dia adalah sama dengan convex lens. So you boleh hafal sekali. Okay, yang tadi sama je. U less than F, U equals to F, U between F equals to 2. Okay, U more than 2F, U at infinity. Same. Okay, jadi concave mirror juga akan dapat karakteristik yang sama. Okay, boom boom, rim wrist, red. Okay, sama. Okay, cuma dia punya drawing is different. sebab dia apply concept of reflection. So ini adalah center, this is concave. So let's say ini F, ini C. C ialah 2F actually. Okay, center of curvature. So if object here, let's say object here, okay, parallel to principal axis, converge to F. Dia macam ni sebab dia reflection. Okay. Okay, lagi satu. Pass through F. Okay. Reflect parallel. So dia meet di sini, you draw image. So image form in front of the mirror, ini adalah real image. Nampak tak? U between F and 2F, real inverted, magnified. RIM. Okay, so ini adalah concave mirror, apply reflection. And then you discuss also about application of mirror. You ada convex mirror, convex, dia wide field of vision. Okay, kenapa? Sebab convex mirror, image dia sentiasa BUD. Sama macam concave lens. Dia sama macam concave lens, BUD. Virtual upright image. So if the image smaller means it will cover larger area. Okay, concave mirror depends on U. Okay, concave mirror kita untuk hasil magnified, you apply contohnya dentist punya tu kan, mirror tu. And then ataupun makeup mirror, you nak your image become bigger, so we use concave. Convex macam rear view mirror dalam kereta, ataupun blind corner mirror, ataupun safety mirror in a shop, ataupun security mirror in the shop. Itu semua guna wide field of vision. So itu adalah overall about chapter 6. So saya ambil masa about 30 minutes to cover everything. So actually this is not enough just to refresh some important points. You still need to read through all the application, okay, the explanation, okay, the law involved in this topic. Okay, so it's no all. Okay, let's go to our discussion actually. So this is question from Ticket to Victory. Okay, question from Ticket to Victory. Okay, we look at the questions. Paper 1 dulu. Number 1. Okay, number 1. Diagram shows an incident ray is directed into glass block. Which direction does the light travel? Okay, nampak? This is should be okay, travel from air lah, air lah. Okay, this is incident ray, point of incident, and this is boundary. So you can see it is directed 90 degrees to the boundary. If you draw normal line, this is the normal line. Ini normal line. Okay, means incident ray is along the normal line. If along the normal line, angle between ray and normal line equals to 0. Okay, if you apply Snell's law, which is sine I over sine R equals to constant or n. Sine I is directly proportional to sine R. If you carry out an experiment to study relationship between I and R, and then you plot a graph of sine I against sine R, you will get a straight line passes the origin. Means if I 0, then R also 0. Okay, So based on Snell's law, we get R0. So if angle of refraction 0 means the light will continue to travel in the same direction. No bending. Okay, no bending. Or we can say no refraction. Okay, so when travel along the normal line, no refraction, travel straight line. So your answer should be A. Okay. If you have question, you just write in chat kalau mana yang tak faham. Okay, tulis dalam chat. Okay. Number 2, at night while riding a motorcycle, Kamaru Zaman could not clearly see what was happening on the road when he closed his helmet mirror. Okay, dia tutup dia punya mirror. Actually mirror di sini kalau it's not actually mirror. Kalau you faham mirror, mirror light tak boleh pass through, actually glass lah. Okay, maybe percakapan kita guna mirror, cermin, tutup cermin. But it's not cermin actually, it's glass because light can pass through. Okay, actually I could say this one is helmet cover, which is made of glass. Okay, I don't want you all to get confused. So it's cover which is made of glass. Okay, so what happens? So this is caused by, as you know that when light travel from air to glass, nampak tak di sini ada bending. So the bending of light, we call it refraction, change in the direction of light. Okay, so this is caused by refraction. Okay, number 3. Where should the object be placed in front of a convex lens for its image is same as the object? Same size. Sama besar. Same size as the object. The focal length of convex lens is f. That's why I want you all to memorize just now. Remember, boom boom, rim wrist, red red. U less than f, U equals to f. Always write like this, then you can memorize easily. Maybe you have another technique, up to you. So I just memorize like this. The 6th position. Okay. Boom boom. Rim rim. Okay. So I want same size. Same size is here. Means U equals to 2F. Okay. Same as 2F. Okay. Okay, if you have question, just write in chat. Tulis dalam chat. Okay, number 4. Okay, ini dalam bahasa Melayu. Okay, tengok ada mesin bahasa sana. Okay, just observe the diagram. Why the light ray bends when passes through a medium? Okay, this one. Okay, the student answer the question. Angle of refraction depends on angle of incidence and refractive index. Okay. So diagram A shows a ray light passing from medium X to Y, while B from X to Z. Arrange the optical density for the medium in ascending order. Menaik, ascending. Yeah. So we just compare from here. So if you look from here, bends towards normal. Means speed in medium 1 is smaller. Speed decrease. So if speed decrease means density of Y is more than density of X, or refractive index of Y than in X. Now compare Z and X. So from here, obviously, you can see light bends away from normal. Bends away means the speed is higher. Okay, speed higher means Z is less dense than X. Okay, or we can write like density of X is more than Z. Okay, combine these two. Okay, uh, relationship. So we get Y is more than X more than Z. So arrange in ascending order means Z, X, Y. Okay, so you will get the answer is A. Okay, number 5. Betul ke ni ascending? Betul. Okay, if suddenly you are not agree with me, you also can write in chat. Boleh tulis di chat sana. Okay, number 5, astronomical telescope. 100 centimeter normal adjustment. L equal O plus FE. Okay. Given that focal length of eyepiece, FE, 40 centimeter, calculate magnification. As we know, magnification is FO over FE. Under normal adjustment, mean the separation between two lenses is FO plus FE. Okay, so means you need to find FO first. Okay, so ini sama dengan 100 centimeter. So you have FE 40 cm means FO is 100 minus 40 cm. Okay, magnification M divided by FE means 60. Okay, 6 divided by 4, you will get is 1.5. Okay, so the answer is C. Okay, nampak ini formula understand this one? Okay, number 6. A block of glass is illuminated by sunlight. The sun is at 50 degrees angle above the horizontal and the bottom of container is completely dark. The container has a depth of 15 centimeter. Calculate width X of blocks. Okay, ini X dia minta you cari X ini. Okay, the refractive index air is 1, glass is 1.52. So you need to find what is the refractive index for glass. Okay, what is given? The sun is at 50 degrees angle above horizontal and the bottom of container is 15. Soalan ni. Okay, from horizontal the line is 50, meaning theta here should be 40, right? Above horizontal ialah 50, so it's 40. container has a depth. Ini ialah 15. Okay, maksudnya ini 15. We want to find this x. Okay, let's find theta 2. Okay, sine 40 over sine theta 2 equals to 1.52. Okay, find theta 2 dulu. What is the answer? Try to calculate. The soalan ni soalan hot. Sebab you calculate first, you tak dapat jawapan lagi. You kena continue. Anyone can give the value of theta 2? That is 25. Okay, now here 25 kat sini. Okay. Can we apply Pythagoras theorem for this one? Or you use tangent? $15. Okay, I get the answer for number 6. I get 6.99. So I round off, I will get 7. Okay, so any mathematics, get 6.99, or we can say it's cm. Okay, mathematics. Okay, number 7. Which path of light ray undergoes phenomenon of total internal reflection? Okay, total internal reflection, it reflected back to the same medium. So kalau you tengok A, ini bukan. C juga bukan. Maksudnya D. Okay, maksudnya dari water go back to water. So itu total internal reflection. Number 8, velocity of light in vacuum given, refractive index of water 1.3. What is velocity of light in water? So ini formula saja. V equals to, N equals to C divide by V. Okay. Okay, just ganti refractive index of water 1.3, speed of light 10 power 3 times power 8, 90. Okay, so very direct. This one you given in the list of formula, in the list, hanya check list. Okay, number 8, the answer is B, boy. Check and see. Okay, number 10. What is suitable manipulated variable and responding variable? First, position of the eyepiece close to the object produce bigger image. Position of eyepiece further from the object produce smaller image. So the further or smaller means the image distance. Position of eyepiece close to the object or further from the object also represent object distance. So for this one, if you want to carry out an experiment, the manipulated variable should be object distance and the manipulated variable should be image distance. Okay. Okay, lagi satu ialah to produce bigger size. Ada size of image juga di sini ya. Size of image means I think it's more suitable to use focal length, because it mentioned about size of image also. Okay, it does not mention about further or closer. Okay, sebab hanya image, size of image, so means the most suitable answer should be C. Okay, kalau ada height of image, tu boleh lagi tepat lah. Ini ialah focus length. Should be number 9. Wait, I check again. Further object produce a bigger image. Sorry focus. How come focus pula? Because focus length ni adalah ini should be a constant variable. Same length. Ini constant variable, sorry. Okay, tadi saya dah mention tadi, if object distance, size of image, better juga ialah height of image, tapi dia tak ada. So the best answer should be B ya. Manipulated variable, object distance, responding variable, image distance. Okay, fixed variable sepatutnya focus line ya. Okay. Okay, number 10, diagram below shows objects standing in front of convex lens. State which of following a characteristic of image form. If you memorize already, you will know the answer. U between F and 2F ialah rim. Okay. Okay, real inverted magnified. So if you cannot remember, you just draw, sketch saja, cuba sketch. Ini optical center. Okay, converge to F. Okay, pass through center, red line. Okay, so image form di sini, nampak tak? Real inverted. Terbalik lukisan saya ni, lari. Mungkin tak sama dia punya scale tu, jadi dia dapat di sini. Okay, should be bigger. Should be bigger. Okay, let's try to draw again. Sebab scale dia tak sama maybe. Okay. Sini. Pass through F. Pass through center. Nampak dia di sini. Patutnya lebih besar patutnya lah kan. Ni dah sengit. Dari situ sengit. Kalau you draw betul-betul guna-guna image dia di situ. Bigger lah. Jadi bila you draw, you tandakan arrow Okay, so real inverted should be inverted magnified. Yes, correct. Sama. Real, yes. Inverted sama. Maksudnya 2 dan 3. Okay, so 10 ialah C. Any question? Ada soalan? Okay, do you have any question? Ada soalan tak? Dah hilang diagram. Okay, so we continue to paper 2, section A. Okay, number 1, you can see from here, you can see the banding. Image bands means refraction. Ini konsepnya ialah refraction. Okay, what is phenomenon involved? So you just write refraction. Kalau phenomenon, kena tulis refraction. Jangan tulis the bending of light. Phenomenon tu dia nak nama reflection, diffraction, interference. So ini refraction. How does the above phenomenon occur? Okay, light travel through different medium and speed change. Ataupun you tulis the change in speed of light when light travel or passes through different density of medium. Itu lagi okey lah. Tulis mula. lebih cantik sikit jawapan. Okay. Okay. The change as light passes through different density of medium. Okay. Okay. Itu ialah how, explain how, bagaimana. Okay. But see, if water replaced with oil, what happens to pencil? Okay. Remember, density of oil is less than water. Or we can say refractive index of oil is less than water. So speed in oil is higher than water. Okay, maksudnya kalau refractive index dia adalah smaller, it will ability to bend light is less. So maksudnya less bend. Okay. Okay, sorry. Ya. Ini density yang betul. Kita nak discuss ialah optical. Okay, ada perbezaan sikit dari segi jawapan yang diberikan. Okay. Optical density. Okay, kita boleh check juga optical density of oil. Jadi kita buat eksperimen untuk ini. Okay, saya nak make correction sikit. Okay, now for this topic we not discuss about the arrangement of molecule, itu ialah density of liquid. This one optical density ialah okay, macam mana light. Okay, how speed of light change when passed through the medium. Okay, optical density of oil is larger than water. Optical density oil is more than water. Okay, means refractive index of oil is more than water. Ini boleh check internet lah. Dia punya value dia, optical density, means oil has larger ability to bend light. Okay, so the answer should be A, more bends. Okay, lebih bengkok. Okay, when we discuss in terms of optical density. Okay, explain what happened. Okay, optical density of oil is higher than water. Okay, so it bends more. Okay, number 2, diagram below shows an object in front of mirror. So this one is convex mirror. Center of curvature is behind. So ini dia virtual. Okay, virtual. Soalan, name the type of mirror. So you boleh tulis convex mirror. Calculate focal length of the mirror. Okay, nampak tak sini? From center of the mirror to the C ialah 20 cm. We know already C ialah 2F. Okay, maksudnya ini F, ini pun F. So 2 to F equals to 10 cm. Sebab for ini dia divide 2 lah, center curvature 2 kali ya. So you will divide 2F equals to 20, F equals 10 cm. Okay. Bahagian C, complete diagram below by drawing one more ray from point X on the object to show formation of image by the mirror. Draw the image form. Okay, lukiskan di sini. Draw one more. Okay, directed to C. Ini kita tulis dash line sebab bahagian ni semua virtual. Sebenarnya light cannot pass through pun. Sebab mirror dia block light, dia reflect. So if pass through C means along the normal line. Di sini normal line, 90 degrees to the mirror. So dia akan reflect balik reverse direction along the same line. Ini straight line. Saya draw without ruler, so itu problem. So dia mesti straight. Okay, ini dia punya reflected dia. Okay. Another one, parallel to mirror. Parallel parallel to principal axis, parallel to principal axis, reflected diverge from F. Maksudnya dari sini, F, dari F, diverge up. Okay. So untuk convex, parallel, okay, diverge from F. Okay. So you nampak in front of the mirror, we put a screen. So you can see the two reflected rays will never meet here. Means there's no real image. Okay, extend to the back. You can see the light ray meet here. So means this is position of image. So image dia ialah virtual upright diminish. Jadi convex virtual upright diminish. Okay, tengok soalan. Kita dah complete ray diagram, dah tambah lagi satu ini. Tambah. Okay. Ini dah complete dah. Okay, state one characteristic of the image. So you boleh tulis virtual satu saja, or upright, or okay, tulis satu saja. Okay, number 3, diagram A shows a coin is immersed in distilled water. Diagram B shows graph or real depth against apparent depth of distilled water. Ni. Diagram C shows identical coin immersed in the seawater, different density seawater, real depth against apparent depth of seawater. Okay, nampak graph dia. Soalan, why does the coin appear closer to the surface of distilled water and seawater? Kenapa nampak dekat? Okay. Refraction. Okay. Or you can say due to light refracted pun boleh. Compare apparent depth A and C. A and C. Nampak ni, ini A. Okay. Apparent depth from surface of water to image. This is apparent depth. Okay. From surface to object, ini ialah real depth. Jadi ini untuk yang A punya. So this is for sea water. Okay, can see the difference. I hope you can see lah. Kena dekat lah boleh nampak. Apparent depth is more than in B. Okay, it's longer. Okay, it's higher pun boleh. Compare density of distilled water and seawater. Okay, density of is larger than distilled water. Okay, density is larger. Okay, next, state relationship between density and apparent depth. When density increases, okay, ingat formula je lah ya. N equals to H divided by small h. Okay, density increase, maksudnya apparent depth decrease. Okay, di sini ya, sebab density refractive index depends on density ya. The higher the density, the higher refractive index. The higher the refractive index, the shorter the apparent depth. Okay. Part C, a fish is at the bottom of the pond, depth 4 meter. Okay, at what depth fish appear visible? Means nak cari apparent depth. So kita ada N equals to 1, meaning ialah air to water. Okay, refractive index given. Okay, what formula that we should use? Kita ada real depth, apparent depth. Okay, kita gunakan formula. N equals to 1.33, so N equals to H divided by small h. 1.33, 4 divided by h. Meter. 4 divided by 1.33. Yeah, Noria, which one? The formula soalan nombor berapa? Noria? Formula sign yang mana? Which formula do you mean? Sign? Which questions? Is it the refractive index? Okay. Sin 40. Oh, soalan number objective. Okay, objective. Go back to this one. Is it? Betul yang ni. Okay, tak apa. Saya tunjuk lagi sekali. Soalan ni dia macam soalan hot sikit. So right here. Okay. Okay, this question you can read clearly. The sun is at 50 degrees angle from above the horizontal. So means in 50. If this one 50 means theta 1 is 40. Okay. So this is angle in air. You want to find refractive index of glass block dulu. Okay. Refracted angle. Sebab ini adalah dia ambil normal line yang ni ya, normal line. So kita ambil okay, normal line yang ni saya buat warna merah takut you tak nampak. Okay, ini normal line. Okay, maksudnya refractive index theta 1 angle of incidence, refractive angle sorry, theta 2 ialah refractive angle. So kita guna formula Snell's law. N equals sin I over sin R. Okay. You want to find refractive index in the medium must be second medium. Apa maksud second medium? I itu mesti air. R itu mesti medium punya angle. Okay, dia selalu macam ni. Okay, sin I in air divide by sin R in medium. If you want to find refractive index of glass, maksudnya sin I in air divide by sin R in glass. Okay, jadi kita dapat macam ni. N equals to sin 40 by theta 2. And refractive index already given. You want to find wait. Refractive index. 1.52 dia dah bagi. 1.52. So you calculate for sin theta 2 as sin 40 divide by 1.52. Okay, calculate for theta 2 again 35 degrees. Okay, you dah dapat angle di sini ialah 25. Dia punya plane ialah vertical plane, plane yang ni plane yang ni. Okay, means this light ray at this plane. Okay, so kalau saya ambil keluar plane tu, you akan dapat macam ni. Bagian ni ya. Ini. Okay, ini normal line. Ini angle theta 1 tadi. Ini angle theta 2. Okay. So dia pergi ke sini sorry, saya betulkan balik. Dia adalah satu, sebab dia kena dekat sini dia macam diagonal line lah. Macam ni lah, macam ni. So sini right angle. Ini 15. Ini X. So for angle theta 2 tadi you dah dapat 25. So gunakan triangle ni. Triangle ni. Gunakan triangle ini. Ini right angle triangle. Untuk theta 2 kita ada opposite dengan adjacent. So kita guna tangent. Tangent 25 ialah X divide by 15. So X ialah 3 times tangent 25. Okay. So 15 times tangent 25, you akan dapat jawapan 6.99 something. Rounding off ialah 7 cm. So jawapan ialah B. Okay. Boleh tak? Okay, boleh tak Nuriah? Okay, so soalan ni dia ada 2 step. Maksudnya soalan hot lah ni. Okay, soalan hot. So we can continue to the next to the section B. Kita sambung section B. Okay, kita lihat section B. The two photograph captured using two lenses, different focal length. You nampak saiz tak sama. What is meant by focal length? Apa maksud focal length? Okay. Distance between optical center and point. Okay. Kalau you ada lens macam ni, okay, ini optical center, ini F, so dia punya distance ialah focal length. Okay. Part 2, using diagram AB, compare, okay, highlight apa yang you nak compare. Thickness, focal length of the lenses, relationship between thickness and power of the lens. Okay, 4 markah. Okay, sini ada 4 pula. Okay, tak apa, kita tengok comparison untuk soalan ni. Compare lens okay, remember untuk lens, you nak dapat image yang bigger hanyalah U less than F, U equals to F, U between F and 2F. Okay, boom boom, rim. Maksud B kat bahagian ni je. Selebihnya ialah same size atau smaller. Okay, yang ni different lenses, kita boleh discuss different focal length. Let's say object placed at the same position, object U same. So if U same, if you use lenses with longer focal length, contohnya, okay, focal length lebih pendek. Okay, kalau focal length lebih pendek, F smaller, F smaller. So you punya object distance akan pergi lagi ke bawah, lebih besar lah maksudnya kan. You more than jadi you dapat image smaller. Jadi yang ni you akan dapat dia punya yang image smaller, ini larger, ini smaller. So you akan dapati untuk lens in diagram A is thinner. Diagram A is thinner, focal length is longer. Yang ni focal length is shorter. Okay. So, kita tulis jawapan. Kalau you nak kaji balik, you juga boleh guna 1 over F dengan 1 over U. 1 over U. Okay. Okay. Lens in E is okay, focal length of A is longer than B. Okay, relate between thickness, okay, the thinner the lens, the longer the focal length. Okay, as we know that F dengan power inversely proportional to focal length, means the thinner the lens, the jawapan jangan tengok jawapan di sana. The thinner the lens, the higher the thinner maksudnya longer. Longer focal length means low power. The thinner the lens, the smaller the power. Macam power rendah dia nipis spek dia. Okay, kalau power tinggi tebal. Okay. Ya, kelas kita mungkin panjang sikit, saya nak habiskan. Kalau you all tak larat nak tunggu ataupun dah letih, you all boleh stop dan boleh continue later. Okay, calculate focal length of the lens. Kita tengok balik soalan yang awal, apa yang dia bagi. Tak ada apa-apa information diberikan ke? Okey, ada. Nampak bawah tu. Okey, power ada 5 diopter. Object placed 30 cm in front of lens, power 5 diopter. So focal length kita guna formula P equals to F, 1 over F. But F mesti meter. Then only we get diopter. Okay. So dari sini 5 equals 1 over F. F Y 0.2 meter. So means 20 centimeter. Okay, so kalau you guna diopter, focal length will be in meter. So you dapat tu ialah 20 cm. Calculate image distance. Okay, already given U 30 cm. Ni dari sini 30 cm. F 20 centimeter. You want to find V. Means lens equation. 1 over F equals 1 over U plus 1 over V. 1 over V, 1 over 30 plus 1 over V. So 1 over V equals to 1 over 20 minus 1 over 30 equals to 1 over 60. So we get V ialah 60. Okay. Magnification. You don't have height of image, height of object. Use image distance divided by object distance. Okay, so you will get is 60 divided by 30 U. So you dapat 2, maksudnya tak ada unit, no unit. Okay, tak ada unit. So magnification 2, meaning image is 2 times bigger than object. Okay, part C, diagram below shows handphone is used. Determine characteristic of lens used for best smartphone. Okay, lenses je. Okay, kita lihat di sini. Type of objective lens, power of lens, IP. Okay, jadi kita akan jawab dalam table form. So let's look at which one is the most suitable first. Pilih dulu baru jawab dalam table. Okay, kita akan pilih untuk objective lens. We will use convex, of course. So you just remove 2 of the concave. Power of lens must be high. Of course, we want high power. Okay, type of lenses. Okay, we use plastic. Ada reason dia kenapa plastic Now most of the spectacles also made of plastic. Okay, focal length must be short. Okay, you can see clearly. I will choose U. Now we want to write in table form. Okay, aspect yang pertama. Write down the aspect dulu. Okay, type of lens. Kita ada second point tadi apa? Power. Power eyepiece dengan focus length. Eyepiece lens, apa material dia. And then kita ada ialah last one ialah focal length Okay, explain suitability to determine a smartphone of a smartphone camera. Kalau smartphone camera kita nak dia, okay, of course kita nak clear and bright image. Tu semua Kita akan explain dia punya reason. Okay, type of lens is convex lens. Power of lens must be higher. Material of the eyepiece, plastic. Focal length must be shorter. Okay, reason type of lens is ialah convex. To produce and inverted okay, higher power, so to produce sharp and clear image. Okay, sebab dia fokus lebih baik. Material of eyepiece plastic, easily to be thin. Okay, senang nak nipiskan dia or compress it. Is it correct my word here? Okay, easy to change its thickness. Can easily change. Okay, focal length shorter, so it is higher power. Okay, then U is chosen because tulis balik yang sebelah ni, because it is convex lens, higher power, plastic and focal. Jadi untuk dapatkan 10 marks tadi. Ini untuk section B. Any question? Ada soalan ke? Okay, no question, then I will continue section C. Okay, number 1, diagram 1.1 shows a car driver driving on a hot sunny day. An image of cloud is seen on the road surface in front of him, but the image of cloud disappeared when he approaches it. Ini panggil mirage. Okay, so untuk konsep mirage guna dua konsep, refraction and refraction. Sorry, the first one. Ini refract. Refraction and total internal reflection. Okay, name state definition of reflection of light. Soalan ni dia bahasa Melayu ialah pembiasan. Maksudnya dia nak ialah bukan reflection dia. Okay, so you all will tulis the change in direction is due to change in velocity atau speed of wave as the wave passes different density. Okay, dalam kes ni light, jadi you boleh guna light lah. Light lah. Okay, saya tukar kepada light. Ini general punya ya. Okay. Explain how phenomenon A happen for marks. Mirage. Okay. Okay, during hot day, layer of air down near the ground is hotter than the above. Huh? Layers of air above it. Okay, so itu yang pertama. Second, hot air is less dense than light from moving cloud travel from less than denser denser air from normal. Okay. When angle of incidence is greater than the light ray experience total internal reflection. Okay. The reflected ray into the observer's eye and observer observe an image of other, yeah, agak panjang tak tahu. So I just write all the important explanation for this one. Okay. During hot day, layers of air near the ground is hotter than layers of air above. Hot air is less dense than cold air. Light from moving cloud travel from denser air to less dense. Dari atas denser, bawah less dense. And refracted away from normal. When angle of incidence is greater than the critical angle of the layers of air, the light ray experience total internal reflection. The reflected ray gets into the observer's eye, and observer observe an image of puddle of water on the road. Why it looks like water? Because it's coming from moving object above, like cloud. Okay, jadi nampak macam bergerak-gerak macam water. Okay, jadi untuk 4 markah ni. Okay, okay, bahagian C, diagram 1.2 shows a light ray. Light ray traveling from water into glass. 1.3 traveling from water into diamond. Okay, ini diamond, ini glass. Okay, soalan. Based on diagram, compare incident angle, refracted angle, refractive index, glass and diamond. State relationship between refracted angle, refractive index. Name physics law involved. Okay. Jadi ini untuk 5 markah. 5 markah. Saya tulis dalam kertas yang lebih besar sikit. First, you compare the angle of incidence. So, yang pertama, angle of incidence in diagram 1.2 is 2 in 1.3. Okay, second, refracted angle into is larger than, okay, then refractive index of glass is smaller than diamond. Okay, you nampak glass punya refracted angle larger, refractive index smaller. Okay, so you boleh buat dia punya relationship when refracted angle increases, refractive index ataupun you boleh tulis juga dalam bentuk the larger the refractive index, sorry, the angle not angle, the smaller the refractive index. Okey, ni pun boleh. Okay. Jadi ini untuk 4 markah. Okay, markah yang kelima ialah what is the related principle ataupun law. Okay, name physics law involved. Jadi physics law di sini ialah refractive index dengan angle ialah N if dengan R inversely proportional. Okay, so means Snell's law. Okay, jadi tulis untuk dapat 5 point, 5 markah. Comparison relate 4 markah. State physics law 1 mark. Okay. D shows a security mirror installed in grocery shop. Dalam kedai, you nampak image smaller. Okay, you are required to give a few suggestions about modification of security mirror to monitor item effectively. Explain your suggestion based on type of mirror, size of mirror, location of mirror, density of mirror, number of mirror used, 10 marks. So ini pun kita nak buat dalam bentuk table untuk section C. Okay, write down all the aspect given. Okay, yang pertama tadi ialah type of mirror. Tulis sini ya. Type of mirror, size of mirror, position of mirror, dia atau bawah, and then density of mirror, number of mirror. Okay, ada 5 point, 1, 2, 3, 4, 5. Modification, type of mirror ialah convex mirror, diminish kecil. Okay, wider field of vision, maksudnya can serve nearly the whole shop. Okay, wider field of vision. Okay, size of mirror is bigger. Okay, receive more light, so image is brighter. So image is clear, bright. Position of mirror higher than the rack. Rack yang ada dalam tu mesti lebih tinggi daripada tu. So no obstacle. Okay, to observe hidden area. Kat dia terlindung tak nampak. Okay, density of mirror must be smaller because you want to put it at higher place so that it is lighter. Okay, easy to hang at higher place. Number of mirror is more. Mungkin boleh letak 2 ke 3 ke. Okay. More places can be viewed. Boleh lihat lebih banyak kawasan. Okay. Example, if the shop is large, so boleh letak a few corners lah. So that can cover the whole area of the shop. Okay. So this one is the question for section C, modification. Okay. So I think that's all. Do you have any question? Ada apa-apa soalan before I end my session now? Ada soalan tak? Okay. So if no questions, so nearly 2 hours today is quite longer time spent for this session. So I have done for chapter 6. Okay, thank you for joining my class today. Bye.